Going live now.
Well, good morning, good afternoon, and good evening, wherever you happen to be in the world. I'm Stuart Clark, and you are very welcome to our celebration of International Moon Day on this, the 20th of July, 2023. This is the second of our annual celebrations, and we're very happy to be partnered with South Korea for the event. I'm very happy now to hear from Antonio Stark, the East and Southeast Asia coordinator for the Moon Village Association.
Thank you so much, Stuart. I'm Antonio Stark. As Stuart has mentioned, I'm the East and Southeast Asia coordinator for Moon Village Association. And I am so happy to have Dr. Nasser here in South Korea with us for the 2023 International Moon Day celebrations. I can already remember the excitement that I had when International Moon Day was announced in 2021. And we actually hosted the first ever IMD celebrations again here at the Gwacheon National Science Museum. We're so happy and thankful for the Gwacheon Science Museum to be hosting the IND celebrations again for this year. And I want to thank also everyone at the Moon Village Association and the IMD organization who have put in countless hours preparing for this event. So I just want to now turn over to Dr. Kang from the National Science Museum to give a brief introduction of what we have in store for the days upcoming from now. Dr. Kang.
Greetings. I am Sungju Kang, who is a PhD in astrophysics here in Gwacheon National Science Museum, and I'm also working as a science communicator in South Korea. I'm very honored to host the International Moon Day here in South Korea on behalf of Gwacheon National Science Museum. Let me begin by explaining how we came to host this International Moon Day event at Gwacheon National Science Museum. Gwacheon National Science Museum, which opened in 2008, is Korea's major science museum with over 1 million visitors per year. The astronomy and space program at Gwacheon National Science Museum is, in particular, have become some of the most popular programs here, with astronomical facilities and observatories here in Science Museum being a major draw. Furthermore, following the successful mission of the South Korea's first lunar probe, Korea Pathfinder Lunar Orbiter, the Danuri satellite, the people of South Korea are tremendously interested in space exploration, especially in lunar exploration. We thought it would be a great opportunity for the Science Center to host an International Moon Day, providing us a chance to make a lot of people aware that there is such a thing as an International Moon Day, while also having a timely event. So in addition to today's formal event, we will have a moon observation tomorrow evening in Korea, where Dr. Nosar and researchers here in Korea will give a public talk. And we will also have a quiz show to give people have a chance to understand some of the myths and facts surrounding the moon. So we will have a variety of the moon-related events throughout the day. Following that, we will present an exhibition of the photographs obtained by the Korea Pathfinder Lunar Orbiter, KPLO, to demonstrate that this is not a one-time event, but rather a continuing interesting in the moon to the South Korean people. I want to thank you, IMD, once again for choosing this International Moon Day event in Korea as their official event. And I will now step aside and leave the rest of the members to carry on this event. Thank you very much.
Well, thank you, Antonio and Dr. Kung. It is the support that we get from people like you who are also willing to put in these countless hours to organize the events that means everything and makes International Moon Day possible. So thank you once again for hosting this year. Now, the International Moon Day is a project of the Moon Village Association. And so here to tell us about the MVA is its president, Giuseppe Ribaldi.
Good evening, good morning, and good afternoon to everyone around the world, and welcome to the second International Moon Day main event. Let me start first thanking our host, which is the Korean National Science Museum. This is very important for us to be present in Asia, and this International Moon Day will give us an opportunity. So I will briefly tell you about the Moon Village Association. It is an organization that has been created in 2017, registered in Vienna, with the goal to act as a platform to bring together stakeholders from all over the world, including space agency, government, as well as industry, academia, industry, as well as the public. The goal of the organization is indeed to foster peaceful cooperation. The organization is a member of the International Astronautical Federation, and we are permanent observer with the United Nations COPUOS. It constitutes of about 600 people from more the 60 countries. So I would like to highlight few of the projects where the organization is involved and some of the results which we have been achieving earlier during last year. The organization is always active in fields which are ranging from the technical to the cultural to the economics. And so what I would like to bring your attention are some of the projects in particular related to the economical field, where the Lunar Commerce and Economic Working Group has published at the end of last year, the Lunar Commerce Portfolio, which is a study where 9 market segments have been identified and where industrial organizations can find information to see whether their own organization, with not necessarily related to space, can fit. Besides this, we have been active in the policy area, and we have created in 2021 the Global Expert Group on Sustainable Lunar Activity. It is a platform where multi-stakeholders from government and space agency have been discussing how to best engage in activity on the moon in a peaceful way. And as a result of this has been a report published called Framework Document for Sustainable Lunar Activity, has been presented to the United Nations COPUOS, all different subcommittee. And we are very active in promoting cooperation at the level of the UN. Other project which we have been working in the technical area is the Architecture Working Group. This group has been defining a possible scenario, architecture, building blocks of different lunar settlement in general around the lunar South Pole. This will include, of course, possible American as well as Chinese and other settlements. You can see behind me an artistic view of one of these elements related to the architecture. Another important aspect is the new generation, the one which is going to basically use and explore the lunar surface in a sustainable way. So we have a lot of activity to engage the future generation. And just yesterday, we had an important event with Yuzhnoye, leading Ukraine space organization, in order to promote new ideas coming from basically a number of startups. And I think this is, we consider also important. Finally, the last project I'd like to mention is the outreach. So we have been active and have an agreement with the Indian Space Research Organization, ISRO, to outreach Chandrayaan-3, which, as you know, has been successfully launched on the 14th of July. This project has been outreached by means of a video competition with students around the world. And finally, and I left on purpose, is the International Moon Day, which is we are here celebrating. And you will hear, of course, more detail from the chairman, Nasser, immediately after me. So with that, I'd like to thank all of you, and I wish you an excellent main event for the International Moon Day 2023. Thank you. Have a good event.
Thank you, Giuseppe. Now, as I'm sure everyone can imagine, organizing a global event such as International Moon Day requires a year-round commitment and strong leadership. The person responsible for this is the chair of the IMD, Nazar Al-Sahaf, and I'd like to invite him now to say a few words.
Thank you, Stuart. Good afternoon, good evening, good morning, everybody, wherever you are, to the second International Moon Day celebration from the Gwacheon National Museum, the National Science Museum in Korea, South Korea. Let me start with giving you the origins of the International Moon Day. In December of 2021, upon the recommendation of the Moon Village Association, an NGO, to the COPAS, the UN General Assembly declared the establishment of the International Moon Day to be celebrated on the 20th of July of every year, commemorating humanity's first landing on the moon. Our first IMD last year was in 2022. The theme was the lunar exploration, coordination, and sustainability. For the inaugural event, we went to Drake State Community and Technical College in Huntsville, Alabama. And one would say, why did we go there? Well, this was the home of the Saturn V rocket, and this is where it all began with the Apollo program. Last year, we had 38 global events in total from 23 different countries. This year, IMD 2023, we are here in South Korea, and our theme for this year is beginning the new lunar journey for humanity. This, of course, is not by chance that we chose to be here this year. This is because the Asia is taking its rightful place in lunar exploration and space exploration, as we can see in India, China, and South Korea. This year, we have actually superseded our goal of 50 global events shared worldwide by 40, or actually over 40 countries. So this year, we are very happy to be here in South Korea. And of course, we have also a telerobotics experience. This year, it will be in 3 different places: Berlin, Canada, and Hawaii in the United States. This will be great for all the students, high school level, where they will actually be able to maneuver a simulated maneuver of a rover on the moon from their laptop, wherever they may be in different places around the world. And they will actually be able to manage and control the lunar rover from their own institute. With this, I welcome you all to the International Moon Day, and let the celebrations begin. Thank you.
Thank you, Nazar. Well, it's time now to hear from some of our distinguished guests and panelists. And the first to speak is So-Young Chung. Ms. Chung is a senior researcher at the Strategic and Planning Directorate of the Korea Aerospace Research Organization, KARI, and she will talk to us today about the Korean lunar program.
Right, so we're just gonna have the video from Gwacheon's side. Gwacheon, if you could turn the video on for the KPLO, and then after that, we can go for Dr. Chung's presentation.
That technical problem, the video is not playing. Can you go with the presentation?
Okay, presentation first.
All right, thank you. So hello, everyone. My name is So-Young Chung, and I'm very happy to join this event today. So I hope we can show you the video of our Korea's first lunar orbiter later on. And today I would like to tell you a story of Korea's journey to the moon. So Korea has a long and rich history, and we have been observing the stars for thousands of years. What you see here is Cheomseongdae, a stargazing tower built during the 7th century. And it's the oldest astronomical observatory in East Asia. But it wasn't until recently that we started working on space exploration. So in early 1990s, South Korea began its national space program, and we initially started out with building small satellites with the help of other nations, then started building applicational Earth observation satellite on our own to be placed in both LEO and GEO orbits. And then in 2000s, we started building our own space launch vehicles. And just recently, we have had successful second test launch of our indigenously built rocket, KSLV-2. And these successes allowed us to expand our space program into space exploration and to begin our work on the lunar orbiter, which I'll be talking about more. So Korea Pathfinder Lunar Orbiter, KPLO, is Korea's first space exploration mission. The development of KPLO started in 2016, and the spacecraft was launched in the August of 2022 last year. KPLO was successfully inserted into lunar polar orbit at the end of last year at 100 kilometers altitude of the moon. KPLO was originally designed for mission life of 1 year, but was recently decided to expand its operation to 3 years. KPLO has 6 scientific and technical payloads, and 5 of them were built by the Korean research institutes and academia. But what I would like to highlight is the 6th payload that was on board KPLO, the ShadowCam. And this payload was supplied by NASA. And as its name implies, ShadowCam can observe permanently shadowed regions of the moon's polar regions. And we hope that the observation made by this payload will make meaningful contributions to the future Artemis missions. And I'm gonna quickly skip through the rest of the payloads. But if you have time, I really recommend you to go visit KARI's website to have a look at more details of other payloads as well. And another payload I would like to highlight is the high-resolution camera RUTI built by KARI. This image of Earth rise taken by RUTI is really beautiful, and I hope you agree. And Luti continues to send beautiful images of the moon, and you can also check the images of other images of Cape Piero on our website. So in addition to the Cape Piero spacecraft, we also built Korea Deep Space Antenna, KDSA, and it's being utilized not only to support our own mission, but also missions of other countries, including NASA's at our own LRO mission. So what's next step for Korea's lunar program? In 2024, next year, Korea will send a science payload, Lunar Space Environment Monitoring, LUSEM, with the help of NASA through NASA's CLPS program. And after that, the Korea lunar lander will be developed, and we hope to land on the lunar surface by 2032 using the next generation Korean space launch vehicle, KSLV-3. So a little more detail about the lunar lander. Korea robotic lunar lander will demonstrate precision soft landing on the lunar surface. It will carry a rover and radioisotope thermoelectric generator. And we will perform a technical demonstration of in-situ resource utilization as well. And we will also investigate and study lunar dust as part of our science mission. And Korean government have recently revised its Space Development Promotion Basic Plan, which is a comprehensive strategy document for our national space program. And it contains a long-term vision for space exploration of our country. So the fourth basic plan, which covers from 2023 to 2027, highlights effort to promote private sector's participation in space and also promotes space exploration. And after the lunar landing in 2032, we are aiming to have Mars orbiting mission by 2035, and then Mars lander mission by 2045. And we also hope to participate in more space, international space exploration programs. So with that, I would like to end my presentation, and thank you very much for the opportunity to share Korea's lunar activities.
So I think we're gonna try to play the video one more time. The audio is not coming. Still not coming. So I think in lieu of audio, I can getting a quick overview of the video. So what you see right now is the Korea Pathfinder Lunar Orbiter, or or KPLO. It is a satellite that we sent to the moon, and it's actually orbiting the moon right now. And you previously saw the launch video, and you saw how the orbit that it took to actually get into a stable orbit around the moon. And you also saw how it was taking pictures of the moon, including the shadow regions of the moon as well. And in the coming days, Dr. Kang has already mentioned earlier in today's talk, but we actually have a photo exhibit that's going to be go on for about a week here at the Gwacheon Science Museum of the photos that KPLO has taken for the last few weeks. So that's just a brief introduction of what the video was all about, and apologies for the lack of audio.
Thank you, Antonio, for stepping in there. Much appreciated. And yes, apologies for the technical hitch there. And thank you, Dr. Chung, for the most fascinating introduction. It may interest you to know that last night I was here in the UK. I was celebrating the Maori New Year, which is based on the lunar calendar, at the Royal Greenwich Observatory in London. And we're very proud of that historic building because it was built in the 1600s. But the observation tower that you showed us today beats it by nearly a millennium. So we salute you for that. And it's one of the wonderful things about this new interest in going back to the moon, that it is an international endeavor, that there are countries and regions around the world that all want to be a part of that. And we are going to increasingly bring that international aspect out as we move through our speakers and into our panel. And so I'd like to move on to our next speaker, who is Garvey McIntosh. And Mr. McIntosh is the NASA attaché at the US Embassy in Tokyo, and he will give us a NASA perspective on lunar exploration.
Well, good evening, or at least here in Japan. My name is Garvey McIntosh, and thanks for the opportunity to discuss NASA's exciting exploration initiative, Artemis. We have successfully flown our first test flight of the SLS rocket and Orion spacecraft. Are you going to show the video, or should I go ahead and speak now?
Showing now.
Oh, should I speak now? Okay, I'll just go ahead.
We're gonna try the video. Yes.
Okay, great.
And liftoff of Artemis 1. It's a new era of pioneers, star sailors, and adventurers.
We're going beyond anywhere we ever went for Apollo.
Splashdown. Orion, back on Earth.
And there's a lot more coming.
Our destiny is always to go and see what's further and what's next.
There actually metal is being bent, shaped, formed to build the things that we're going to use.
We are going. This is reality.
NASA is at a historic inflection point, poised to begin the most significant series of science and human exploration missions in over a generation.
Astronauts will live and work in deep space, and will develop the science and technology to send the first humans to Mars.
I'm really looking forward to all the science we will conduct on the moon, the samples we'll bring back, the knowledge we'll gain from understanding the lunar environment better than we ever have before.
The more nations and companies at the moon, the more we learn, increasing our capabilities while strengthening things right here on Earth.
We are going to the moon to learn how to live on other planets for the benefit of all. Let's go.
Thanks for playing that video.
And for more NASA video.
And again, my name is Garvey McIntosh, and I really appreciate the opportunity to discuss NASA's exciting exploration initiative, Artemis, where we have successfully flown our first test flight of the SLS rocket and Orion spacecraft that you saw from the video. Our overarching goal is to create a blueprint for a long-term human presence and expand exploration throughout the solar system. Right now, we're aiming in the long term to send humans to Mars, using the moon to help us get there. This effort would not be possible without collaboration with our international and now industry partners. The steadfast support is a collective vision. To achieve this, we'll establish a cadence of missions, Artemis missions, to lunar orbit and lunar surface, for both scientific discovery and to learn together how we can live and work on another celestial body. Under Artemis, we will continue to push the envelope in humanity's quest for knowledge. We plan to send more robots and humans to study more of the moon than ever before, learning how to live far away from Earth for longer periods of time. We'll make new discoveries and gain a better understanding of what resources are available on the moon to build the first long-term presence on the surface. This quest started with Artemis 1. And as you can see, the first slide is Artemis 1. Artemis 1 was our uncrewed, can we go back to Artemis 1? Thank you. Artemis 1 was our uncrewed flight test of the Integrated Space Launch Systems rocket and the Orion spacecraft. As you saw in the video, earlier on November 16, 2022, we lifted off from NASA's Kennedy Space Center in Florida, flying a 26-day mission around the moon, sending Orion further than any spacecraft designed to carry humans and return them safely has ever gone before. We challenged Orion, and it performed wonderfully. On December 11, 2023, Orion splashed down on the Pacific Ocean off the coast of California, where a team was waiting to recover the spacecraft and bring it back to the United States. Since returning the vehicle to land, we removed the scientific payloads inside and inspected the capsule, learning all we can before we fly our astronauts on to the next mission. Next slide, please. Hardware for future Artemis missions is already in work or completed. Can we go back to that one? The Artemis 2 Orion spacecraft, which will carry crew for the first time, is at the Kennedy Space Center in Florida, undergoing final assembly before integration with the European Service Module. The Space Launch Systems, or SLS team, has completed all the booster segments, and the 4 flight engines and all the major components for the core stage have been manufactured. Next slide. Oh, we're already on that slide. This spring, we announced, okay, go back. Please. Okay. This spring, we announced the 4 astronauts that will fly around the moon on Artemis 3. This is an international crew made of 3 Americans and 1 Canadian. You should see the excitement all around the United States and the whole world that surrounds them wherever they go. It's really inspiring. They are starting a rigorous training program where they will receive detailed lessons on Orion and SLS systems, learn to operate and monitor systems for all phases of the mission, and how to respond in emergency situations. Next slide. Artemis 3's Orion is being assembled right now with the crew module in Florida and the European Service Module in Germany. We're very excited to see the first woman to the lunar surface on this mission. We've completed SLS's RS-25 engines for Artemis 3, and the core stage is coming along with proof testing complete on the liquid hydrogen tank and the liquid oxygen tank in production. Next slide. SpaceX was awarded the contract to build a landing system to put humans on the moon for Artemis 3 using a version of their Starship launch vehicle. In addition, we awarded tasks to Axiom Space to develop spacesuits astronauts will wear when they walk on the lunar surface. Next slide. Suppliers for Artemis 4's Orion are busy machining the components for the spacecraft, and the European Service Module is coming together in Germany. Development is well underway for the SLS we'll use on Artemis 4 to deliver crew and cargo. We'll introduce the exploration upper stage for this mission and build the next mobile launcher to account for increased rocket height. Next slide. On Artemis 4, though, we'll see an astronaut step foot inside our lunar space station, Gateway, where our lunar astronauts will stay between surface trips, doing science and learning more about how to live off the planet. NASA's Gateway partnership with the European Space Agency, the Canadian Space Agency, and the Japan Space Agency, JAXA, will expand to including other partners that will contribute to the small space station. Partners will lead hardware and science instruments developments while participating on science teams and in science data sharing. Over the past year, we've added a lunar lander to Artemis 4, with the human landing system provided by SpaceX as well. Next slide. As you can see from this slide, we have a very solid plan laid out through Artemis 4, with hardware for each of the elements either completed or in construction, and we have clear goals. Over the past year, we reviewed our exploration strategy and developed specific objectives that act as guideposts to ensure we stay integrated and clear about what we need to do on the moon to prepare for sending humans to Mars. Underpinning our approach is the belief that it's going to be a global effort, not just by the United States, but working with many international partners. Next slide. Many countries have a role to play in this journey back to the moon, and we need our collective efforts to make this plan a success. As I mentioned earlier, our international partners are contributing hardware like the European Service Module for Orion and habitats and components for Gateway. However, science is front and center on Artemis because science is what will enable us to learn how to safely live and work on another world. And our international partners are providing several instruments and payloads to help us learn. The European Space Agency, Israel, Germany, Italy, and Japan all flew payloads aboard Artemis 1. Their experiments are helping us understand the radiation environment better and test new technologies. Down the road, 2 of our early science payloads aboard Gateway were provided by the European Space Agency and the Japan Space Agency, JAXA. These instruments will help us understand how to keep astronauts safe, looking at the effects of space weather and how it can form models for cancer, cardiovascular, and the central nervous system effects on Artemis crews aboard Gateway. Other countries are looking at sending their own payloads and satellites to the moon, with several missions and proposals or in the process of formulation. Next slide. Our focus on the moon is a global effort, and the things that we do will carry precedent. This means that how we go is as important as what we do. In the spirit of peaceful exploration, it will mean adhering to our values of openness, transparency, shared data, and a commitment to norms that help us work together. We're helping establish that playing field through the Artemis Accord, as you may know. The Artemis Accords are a set of principles grounded in the 1967 Outer Space Treaty, by which signatories commit to behave in a rule-based, responsible way in their space exploration initiatives. To date, I think a couple are mentioned. To date, 27 countries have joined the Artemis Accords and committed to establish a safe and peaceful and prosperous future in space, including Spain, who joined before, and a few other countries that joined recently. Additional countries will sign the Artemis Accords in the months and years ahead, I'm sure. Working with both new and existing partners will add new energy and capabilities to ensure the entire world can benefit from our journey of exploration and discovery. Next slide. We all know that this will not be easy. Artemis is the most complex endeavors that humans will ever have embarked on. And you can see it's a global endeavor. Many countries have a role to play in this journey, and our collective efforts are needed to make this plan a success. A coordinated effort where we invest and build together is the smartest and most efficient choice. We're going to learn how to live and work on another world. And to do that takes more than just one nation. We invite all who want to go with us to join us. As the video talked about, we need to go together for all humanity. Thanks for this opportunity. I'm really happy to be talking to you today. And we're grateful for all of your support. And we look forward to working with many countries and companies, industry, as we go forward in the Artemis program. Thank you very much.
Thank you, Garvey. Your message is an exciting one and an inspirational one. And we're looking forward to hearing more from you later on in the panel discussion. But before we get there, we have one final keynote speaker, and that's Tonya Ladwig from Lockheed Martin. She's the VP of Human Space Exploration and will talk to us today about the Orion crew capsule.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing under the ML. And here we go. Hydrogen burn-off igniters initiated. 3, 2, 1. And liftoff of Artemis 1. We rise together. Back to the moon and beyond.
Now the core stage continues to power the flight of Orion. We have core stage main engine cutoff. It commits us to a lunar trajectory. With the Earth in the background and the moon is our destination, Artemis generation, we are going.
Orion spacecraft bringing its 25.5-day mission to an end. Splashdown. The latest chapter of NASA's journey to the moon comes to a close. Orion, back on Earth.
Thank you for the introduction, Stuart, and thank you all for inviting me to celebrate International Moon Day with all of you. I've seen that video so many times, and every time I get chills. It was such an exciting end to 2022 with our Artemis 1 mission. Orion is the only human-rated deep space exploration vehicle in existence, and after the recent Artemis 1 mission at the end of last year, it is the furthest traveled human-rated spacecraft ever, traveling over 268,000 miles from home and a total of 1.4 million miles. As Garvey already highlighted, NASA and Lockheed Martin aren't stopping or even slowing down. Earlier this year, NASA announced our Artemis 2 crew, Commander Reed Weissman, pilot Victor Glover, mission specialist Christina Cook, and mission specialist Jeremy Hansen from the Canadian Space Agency. These are the people that our team have the honor and the privilege and the obligation to protect. For Artemis 2, we will have a crewed test flight that is 10 days long. We'll orbit the Earth while we test the crew-specific equipment that's new to Artemis 2. So things like our environmental control and life support system, we call that ECLIS, the displays and controls where the astronauts will interact with the vehicle, and even the universal waste management system, or as we call it on Earth, the toilet. Once we have those systems checked out, we'll commit to a trans-lunar orbit, which will take our astronauts around the moon for the first time in over 50 years. And as Garvey already highlighted, we aren't stopping with Artemis 2. If you could see the Neil Armstrong Operations and Checkout building at Kennedy Space Center in Florida, you would see our Artemis 2 crew and service modules finishing environmental testing, getting ready to stack later this summer, and our Artemis 3, 4, and 4 crew modules in various stages of buildup, preparing for the missions where we will return to deep space, dock, and land on the moon once again. The Orion program is already an international program. ESA and Airbus deliver the service module to us to integrate with the crew module to test and prepare for launch. It isn't just Orion. The greater Artemis missions are international missions as well. International collaboration is key to us accomplishing our return to the moon and expanding to exploring to Mars. As a representative of Lockheed Martin, I invite all of you to reach out to us for opportunities to partner, to see how your nation can participate in the Artemis missions. We are working on a variety of payloads and technologies needed for a successful lunar economy, and we love new ideas and are looking forward to forging new international partnerships. Thank you again for allowing me to be here with you today. Back over to you, Stuart.
Thank you, Tonya, and thank you so much for being here with us and sharing all of your news and your obvious love and excitement for this situation and endeavor that we're engaged in. And it's a thank you to all our speakers for their introductions. This is a truly, truly fascinating subject, a forward-looking subject, and one of peace and cooperation. So exploring the moon is now so clearly on the agenda for so many countries that I'd now like to invite all our speakers to turn back on their cameras and join us now for our virtual panel discussion about this exciting future we're looking at. And we're joined as well by Michelle Keegan, who's the Program Director at the Australian Remote Operations for Space and Earth Consortium, known as AROSE, and Gordon Osinski, who's known as Oz, who is Professor with the Department of Earth Science at Western University in Canada. So thank you all for being here. We are really grateful for your time and your expertise. And what I'd like to do to start with is I would like to go around each of you in turn and so get a little bit of a quick fire round in to warm us all up and get us going. And I'd like your short answer to a simple question. Why the moon? What is it that draws you to the moon? What is it that perhaps you hope to discover by our exploration there? And I'm going to start with our newcomers first. And the person who is on my direct right is Oz. What is it about the moon that draws you?
Good morning from the Eastern time zone of Canada. And well, first and foremost, I'm a scientist, geology to be specific. And so I think for me, the moon holds the answers to some of the most, important and unanswered questions facing the scientific community. So science-driven exploration of the moon.
Wonderful. Michelle, you're next in the hot seat.
And good evening from Australia. And, for us at AROSE, we're focused on the moon as part of the Australia's Moon to Mars program. We're a consortium and we're really focused on taking Australia's remote operations capability to space. What we want to do is leverage our long experience from the resources sector and take that into the design of Australia's first lunar rover. So it's really about demonstrating capability on the moon.
Wonderful. Tonya, what about you?
Well, I would say it's twofold. One, as we develop these technologies that we need to get to the moon and beyond and to Mars, there's so many benefits it will have for society back here on Earth as we do that. But then really thinking about, the fact that we're still uncovering science based on the regolith that was found on the Apollo mission now, right? So as we start to go to the moon again, with the technology that we have 50 years later, I'm excited to see the unknown, the science, the exploration, and the discoveries that we'll have that we can't even anticipate today.
Yeah, bet your bottom dollar that I'm going to ask Oz about that any moment now. So, but before we do that, let's go back over to Korea. And So Young, what is it that draws you to the moon?
Right, so I think we were given all the right answers already. So there's science, technology, inspiration, and also politics, we should admit. But I think the ultimate answer is because the moon is there. The moon is there. It's human nature and human destiny to explore.
Fabulous answer. Yes, it gets harder for each of you as we go down the list. So when we get to our wrap up, quick fire round question, I'll test my memory and see if I can go in reverse order. So what about NASA? What about for you? What makes you look up and see the moon?
Well, so many good answers already so far through it, but I just think from my perspective, it's time. Back during the Apollo era, we went to the moon successfully 6 times between 1969 and 1972. After that, we embarked on the International Space Station. During the Apollo era, we kind of really proved that we could go to kind of longer distances, go to the moon for short-term stays. And then I think through the International Station, Space Station, we realized that we know how to keep humans safe and for longer periods of time, 6 months, and we've been up there for a year. So I think, one of the main goals of NASA is to extend human presence in the solar system. And so you have to do that incrementally. So I think with the lessons learned from the first time we went, to the moon, to the Apollo era, combined with what we learned from the International Space Station, it's just the next step to continue to explore the solar system and extend our human presence. So I think it's a perfect timing. Now we have a really good infrastructure with partners, and international partners are growing. Many countries are involved in space, and space activities and the international partnerships are growing. And now industry is really, really taking off. So I think it's really, really a good time to do it. And I think it's I think it'll be a global effort, and I'm really excited about it.
Thank you, Garvey. Back to Korea for any final thoughts from NASA, and what is it about the moon that fascinates you?
Well, to look up into the moon, like my colleague just said, and almost everybody else took all the great answers. But anyway, it's a sense of pride also for emerging space countries to be a part of this. And of course, the moon being the closest celestial body, that's only natural for us to aspire to discover it more. I believe the journey or going back to the moon will create so much more new technologies that we would need for deep space exploration. Yes.
Thank you. Now, before we go on to talk about how we're going to explore the moon, how we're going to get the people there, let's go all the way back to the beginning of the story. And so, Oz, if I can turn to you, take us all the way back to the beginning of the moon and the solar system itself. What do we know about the way it formed, and what would we like to know about in more detail?
Yeah, absolutely, Stuart. And, Tanya already mentioned that we have the Apollo samples, and those have told us a lot about how the moon formed. I think most scientists would agree. We have a pretty good idea that not long after our own planet formed, something the size of Mars hit the Earth. The Earth was all but destroyed, and out of this chaos, essentially, the Earth reformed and the moon formed in an orbit around us. What happened next, like in the next 500 million years, 500 million years, remains much more speculative. And that's actually one of the major reasons we want to go back to the moon. If you've been following international plans, you'll have noticed that Artemis and most other individual nations are heading for the South Polar region. Part of that is volatiles, is looking for water ice. But perhaps one of the most scientifically more interesting questions to me anyway, is that this region of the moon lies on the edge of what we call the SPA, the South Pole Aitken Basin. This is the largest and oldest impact basin on the moon, about 2,500 kilometers across. So, it's the remnant of a gigantic impact on the moon. We don't know when that occurred. The Apollo samples led to this idea of a late heavy bombardment, where the moon and our Earth, by corollary, was impacted around 4 billion years by lots of objects. And so pinning down the date of this basin, it's up there in the NASA's Decadal Survey. Here in Canada, it's a prime driver too. And so we need to bring back samples again from the South Polar region, where Apollo didn't go, to really pin down the age of that basin. And, it will tell us not just about the moon's history, but the early history of the solar system, of the Earth, and even actually help us figure out when life evolved on Earth. So really important to be going back and understanding that early part of the solar system history.
Fantastic. And this is one of the perennial fascinations for me about our astronomy and our solar system exploration program, and just science in general, is that how we are constantly understanding more and more, adding to our knowledge. And some of the things that we thought were fixed can be overturned by new data. When I was a student studying astronomy, we thought it was all pretty cut and dried about the age of the moon and this period of late bombardment. So it's fascinating to hear that there are still things to learn, and that there might be new textbooks to be written as the result of all of this work. Now, you mentioned some of the wider implications of studying the moon for our understanding of some of the origin of events in the solar system, such as origin of life on Earth. Unpack that a little bit for us. Tell us about how you take the knowledge that you have and that you will learn from the moon and its origin and apply that sort of across the solar system.
Yeah, for sure. So the basic, it boils down to the fact that the moon hasn't changed much over 4.5 billion years. After it formed, it's remained there. It's been hit by more and more asteroids and comets. But unlike the Earth, its surface really hasn't been, it hasn't got plate tectonics. It's not Venus that's been completely resurfaced by cataclysmic events. And so it's been referred to as a witness plate. The moon has recorded essentially everything that has happened in the inner part of the solar system since about, 4.4 billion years. We do not have that record on Earth. I cannot go out and do field work and look for rocks of that age on Earth. They just don't exist anymore. And so by going to the moon, we can find rocks from that, early period of solar system history, analyze them, bring them back, and hopefully, again, pin down some of a big part of it is the timeline, is when certain events occurred, from about 4.5 billion years to about 3.5 billion years. And so for that, we absolutely must bring back samples to Earth to analyze in our labs with techniques, that didn't exist 50 years ago.
It's absolutely fascinating. So we're going to move on to Soo-young now, because to get the kind of answers that you're talking about, Oz, we're going to need to send either robots or humans up there to the moon. And we'll deal with the human exploration in a little while. But first, I want to talk a bit more about robotic spacecraft. But before I do, let me remind all of our panelists here that this is not a one-way street of me just asking you questions. If any of you would like to chip in with any answers or comments or even questions for your fellow panelists, just let me know, raise your hand or use one of the Zoom gestures, because this is our time to hear from you. So please feel free. Don't wait to be asked to speak, just to jump in. But Soo-young, you talked to us earlier about the Korean Pathfinder lunar orbiter that's currently circling the moon, and many, many congratulations on that mission. Tell us a little bit more about it. How is the spacecraft doing? What kind of data is it sending back? And what does it feel like to be on the receiving end of that data and to know that your spacecraft is up there?
Right. So to answer your last question first, how does it feel like to be on the receiving end? It feels great. We are one of the latecomers, and growing up, I never thought that Korea would be part of the lunar exploration. So it's really great. It's not just me, it's the entire nation, our next generation. So there's a lot of excitement going on here. And to give you some latest update about our KPLO mission. So I mentioned already that the KPLO's mission life was extended to 3 years. So that means we can do a lot more science with KPLO. And so what is it doing right now? KPLO has 6 payloads. And I already mentioned NASA's shadow cam that's observing permanently shadowed regions, and the high resolution camera built by Kari that's been, sending us back amazing imageries of the moon. And there are 4 other payloads on board, and 3 of them are actually scientific payloads. And I'm not a scientist myself, but just to give you some more details. So there's a wide angle polarimetric optical camera called POLCAM. This is developed by Korea Astronomy and Space Science Institute. And it can acquire it's difficult to pronounce, polarimetric images of lunar surface, including the far side of the moon, to investigate the characteristics of the lunar regolith. So this payload is very meaningful because it's the first polarization observation that we're making from the lunar orbit. Although we've had cases where this observation was made with ground-based telescopes. And the second scientific payload is gamma ray spectrometer that was supplied by Korea Institute of Geoscience and Mineral Resources. And this payload can investigate the chemical composition of the lunar surface materials by mapping the special distributions of gamma ray energy. And another scientific payload that we have is KPLO magnetometer, KMAG. This is developed by Kyunghee University in Korea. And as its name implies, it can measure the magnetic strength of the lunar environment. And last but not least, we actually have one technology demonstration payload, DTN payload. This is developed by Electronics and Telecommunications Research Institute. And this payload successfully validated the interplanetary internet connection based on the delay disruption tolerant networking. And while going to the moon, KPLO sent video and photo files of the popular Korean group BTS music video from the distance of more than 1.2 million kilometers to the moon. So I think this is a very good demonstration for publicity of this mission. So KPLO is still ongoing, and we still have 2 more years of operation. And I'm sure that our scientists and engineers will do great research with the data that they receive. And I look forward to the scientific discoveries that we'll be making. And just to let everybody know that we will make this data available to the rest of the world, to the scientific community.
Fabulous, thank you. Yes, it's important that we test the communications routes to the moon, because when the astronauts are up there, they're going to want to watch music videos just the same as all the rest of us down here on Earth. Now, you said that Korea was sort of a late at coming to this party. Well, I don't, I don't like to think of Korea as a late comer. I like to think of you more as one of the pioneers of this next phase of lunar exploration. Let me bring in Garvey.
Sorry, yeah. So I just wanted to mention, being in this position, being the NASA representative to Asia, I had a chance to really work closely with Kari on the KPLO mission and be involved in that. And just wanted to say, really congratulations to Kari. And I think it's one of the things that I've seen in my career at NASA that I think is really exciting to see countries like Korea lead missions and allow NASA's participation. We've seen that a couple of times. India's Chandrayaan mission, KPLO's mission, as So-Young just talked about, in terms of letting us be involved with the shadow cam instrument. So I think that's one thing of space, one aspect of space that I think has really, really transformed the space industry. We're seeing countries like South Korea, ROK, leading missions and making discoveries. And then from a NASA perspective, letting us be a part of that. And we have an important instrument like shadow cameras up there that I think is really, really going to give us a lot of really good information about good science and data about, the permanently shadow created of the moon and maybe water ice there. So I just wanted to say congratulations, Korea. And from a NASA perspective, thanks for letting us be involved.
Thank you, Garvey. Now, before I go back to So-Young, we've talked now in passing just a little bit about these permanently shadowed craters and the importance of this South Pole region. Oz, I wonder if I could just pop you back on the spot as our sort of resident geologist here. Tell us about these permanently shadowed craters, where we find them on the moon, and why you get a crater where the sunlight can never get to the bottom.
Yeah, so these are, PSRs is what you might see as the acronym thrown around. So permanently shadowed regions. These are, dominant around the South Pole region of the moon because you have, a big hole in the ground. The sun is always at a very low angle to the horizon. And so what it means is that, the sunlight never reaches the bottom of these craters for literally billions of years. It's not something that ever occurs on Earth. And so the idea is that over time, molecule by molecule, H2O, water, will go into those depressions and get trapped. And so, we've had detections from orbit. We want to get there on the ground to really prove that there is water ice in them. But again, ShadowCam is also a really amazing payload on the Korean spacecraft because it's the first time we're seeing anything but, darkness in these craters too. So it's an exciting time and, a new part of the exploration of the moon that, again, we didn't even consider or dream about existed on the moon when we went with Apollo.
So thank you, Oz. So the Korea Pathfinder Lunar Orbiter is clearly a success, So-Young. So now the pressure's on to follow that up with more success. So tell us a little bit more about the forward-looking program that you've got of lunar exploration.
Right. So I did already mention that we're currently working on Korea lunar lander, and we want to demonstrate precise lunar landing using this spacecraft. And we will have a number of scientific payloads and also a technology demonstration payload, including, using a radio thermoelectric generator, ISRU tech demo, and things like that. But what I didn't mention in the presentation is that before we do this mission in 2032, we are going to have a demonstration mission to validate the performance of the KSLV 3, which is our next generation launcher. And so we'll do that in 2030, and then we'll also send a lunar landing demonstrator in 2031, and then finally we'll do our lunar lander mission in 2032. So we will have a series of missions accumulating and up to the lunar lander. So that's one thing that our engineers are working hard on. They are, they're not going home sometimes, because they are working on this, plans, and we need to make sure that we get all the budget and the program starts on time to make sure that we get there by 2030, 31, and 32. And after that, like I mentioned, our government has put a long-term vision forward. So we also want to dream about Mars missions, and so that's something that we only have on paper right now, but our scientists and engineers will start working on that as well. So we have a lot happening here, a lot of planning and scientists and engineers working together.
Yeah, it's very, very exciting to hear about all of this research that's going on in the future program. Now, Michelle, I'm going to bring you in here because we've heard a bit about this robotic exploration that's going on. We've heard now about the permanently shadowed regions and the interest that we have in those. But I want to speak to you about this concept of resources on the moon and how that works with these permanently shadowed regions. And when we talk about resources on the Earth, we sort of naturally think about things like minerals, or maybe petro or sort of sort of carboniferous sort of petrochemicals and things like that. It's different on the moon, though, isn't it? Talk us through what we might be thinking about when we talk about resources from a lunar perspective.
Yeah, and you're right. On Earth, we think about exploring, extracting, processing minerals. And, right now, most of the focus is really on the minerals that are needed to help support our decarb journey. But yeah, on the other hand, and as Oz already spoke, the most valuable resource on the moon that we're focused on is water ice. And the mission for the rover that we're designing here in Australia is all about transferring regolith to an ISRU facility so that we can extract oxygen from that. So I suppose if you kind of look at all of this, when you look at resources on the moon or on the Earth, it's all about really trying to find sustained presence on both the Earth and the moon. And it's really just via different resources. So, for us, if we kind of think about things in that way, what we're actually really focused about also in our exploration to the moon is about how do we foster further opportunities for collaboration around both technology and knowledge sharing so that we can accelerate paths that we both have to explore more and understand more, as Oz mentioned, about the moon and Earth.
And how do we get to those resources on the moon? And I'd like you also, in answering that, to talk a little bit about your organization, Arose, because you've got some specific expertise in Australia in remote operation that you're hoping to bring to all of this.
Yeah, and Arose is a member-based consortium. We have a number of members. We have around 15 across Australia and some internationally, and really we were formed based on a vision to bring the remote operations capability largely from the resources sector to space so that we could optimize that and improve what we do and bring that back to Earth. And if you look at some of the mining companies or the resources companies here in Western Australia, over the last 10 or 15 years, we'd say that really what they're doing is, or have been doing, is pioneering remote operations on Earth. Just as, you know, I think if you think in a different way about pioneering exploration on the moon, up in Western Australia, you know, great example of one of our members is the remote operation they have from Perth. So 1,700 kilometres away from a resources district in Western Australia, they're moving around 1 billion tonnes of material a year. It's over 300 million tonnes of ore, and they're doing it via automated trucks and automated trains. And so, yeah, really it's about how do we take that knowledge, that experience, we're doing this 24/7 and have been doing for many years, and take that into the design of our lunar rover. We want to take the resources sector along the journey with us to the moon so that ultimately we can both learn. You know, we've been learning for many years about what it takes in operations on Earth, and if we can start to converge solutions on how we explore in a much smarter way on Earth, if we want to get to a smaller footprint, we want to get to minimal energy, we want to look at zero emissions, zero harm, and do everything in a sustainable manner, we're really starting to collaborate and think different, or think from you know, very different places, but we're trying to converge the solutions to get there.
Thank you, Michelle. And this has become one of the very foundation stones, I think, for me, of the lunar exploration effort, is that because the lunar environment is so different from the Earth, we have to be very, very smart about the way we use resources to get the most out of those resources, to do to use them in the most efficient way possible so that the benefits are there for future generations. And everything we learn in that journey of doing that there can feed back into how we treat the Earth in a more sustainable way. So this, as I say, is one of the founding sort of stones for this lunar exploration now. Well, when it comes to landing on the moon, the events of the late 1960s and early 70s, you know, bring one country specifically to mind. And I'm talking, of course, about America and its Apollo moon landings. And Garvey, as we've heard from you, you know, NASA is preparing, in collaboration with other countries, its Artemis mission to land astronauts on the moon. It's clearly interested, as you've explained to us, in fostering these international cooperations. And you mentioned the Artemis Accords earlier on. Tell us a little bit more about those accords, how they come out of the 1967 Outer Space Treaty, and what they commit the signatories to.
So they don't really necessarily, thanks for your question. So first of all, it wasn't meant to necessarily replace the Outer Space Treaty. It's more meant to kind of to enhance it, or just kind of give us a set of rules and kind of, you know, rules of the road, if you will, to kind of move forward in space exploration in a peace and sustainable way. And so actually the Artemis Accords are a non-binding agreement. So it's not a legal agreement or anything. I just think it's a set of rules that when we were canvassed international partners, who were like-minded countries that wanted to go back to the moon with us, or together. I think there was an agreement there that there was kind of maybe some things missing in terms of making sure that, like we said, it was a peaceful and sustainable way. And so that's kind of when we started the discussions on Artemis Accords. And just in a short period of time, we had 8 countries that started the Artemis Accords together, the original signatories. And now we have, I think, about 27 countries who have all signed on to the Artemis Accords. So it's not really, it doesn't commit you to anything necessarily. It's not a non-binding agreement, but it's just kind of an agreed set of principles to make sure that, that when we go together, to work together, and as I said before, sustainably and peacefully as well. So,
indeed. Now, one of the great benefits of space exploration is the telecommunications, navigation, and all of these services that now feed into every part of society on the Earth. And there are many countries around the world that do not yet have space programs, but would like to develop them. They would like to be part of this future journey to the moon and to using space in this sustainable way to bring the benefits to their own countries. When we are talking about those developing countries, Garvey, what role can they play? How can they partner and be part of all this endeavor?
Yeah, I mean, that's a great question, and something that I think we, at least in the office I am in the International Relations office, struggle with every day, because every country, if they do have a space station, we've seen a lot of new countries, at least in the region here in Asia. I think the Philippines just developed a space station not too long ago. Malaysia just set up a space station a long time ago. And we've had discussions with numerous countries about how we can work together, not necessarily in space exploration, but more than earth science and other areas as well. And so, you know, each country has developed a space agency for their own country's benefit. And I think we have to respect that. We can't, you know, tell countries what to do. But if countries are interested in working, such as we heard with KPLO, you know, when we had a discussion with Korea a few years back, they said they were interested in doing their own indigenous mission, and they would invite us to join. And so we had to listen, and we were very interested in obviously having an important payload on the shadow cams we mentioned earlier on it. But I just think, you know, NASA being our history, sometimes it's a little bit challenging for NASA to just be good listeners and really be an understanding of what's important for each country. So I think we're willing to discuss and talk with many countries, but I think first we have to find out what makes that country tick, why they developed the space station, why are they involved in space activities, and then we can find areas of synergy. And if that happens to be in space exploration, obviously Artemis is a very big focus, as we've heard today, at NASA. So we're very much interested in partnering in that area, but also interested in partnering in other areas as well.
Yes, I hear exactly what you're saying, Garvey. Thank you for that. Here in the UK, I'm part of the UK Space Agency's Earth Space Sustainability Initiative. And one of our jobs at the moment is to listen to countries and organizations around the world, regardless of where they are in their spacefaring journey, to find out what they are wanting to achieve with all of this and how we can work together for a sustainable future. Well, let's go back into the room at Korea there, and we'll go to our NASA there. As the chair of International Moon Day, you're in an excellent position, I think, to have gauged these levels of interest in lunar exploration around the world. So tell me about your experience of the appetite of the different countries around the world for going back to the moon.
Thank you, Stuart. I think it's great appetite. I think it's increasing from what we've seen since last year. The International Moon Day is a very new entity, and we had 23 countries participating in global events. This year, we're much more. I mean, our goal was 40, but we have achieved more than 42 nations. So with 51 global events compared to last year of 38. So just in a matter of just 1 year, we have at least 10 emerging space countries joining us this year. So the appetite is definitely there. But what I would think is important for space emerging countries when they look into space exploration is to reflect upon the added value of such exploration to their own society, to their own needs, and not getting taken into the hype of space exploration as other countries who have vast experience over decades and decades. So it is important, I think, in my view, my personal view, it's important for any emerging space country to look inwards and see how would that benefit their people, and build upon it from that perspective. And that way they can actually gain more. This is what I call the added value, whether it's building capacity, increasing research and science, going all the way back to the school system. This is really where this is actually the added value. Not really get caught up in the hype of trying to do something that is basically vast technological leaps. You would need to have quite a bit of technology-based industry. Thank you.
It's fascinating, and it brings a big smile to my face to hear that the number of countries that are participating in International Moon Day this year is 42. Now I don't. I see from the panel there might be some recognition there, because I'm not sure if this is peculiarly British or not. But a great humorist and writer called Douglas Adams wrote a novel called The Hitchhiker's Guide to the Galaxy. And in this book, humankind built the largest computer, the most powerful computer you could possibly imagine, to answer the ultimate question. And it was the question of life, the universe, and everything. And this computation, according to this novel, was so long and complicated that it took many thousands of years for this computer to come to the answer. And when the ancestors of the people that originally built the computer went down into the cavern at the correct time to hear the answer, the ultimate answer, the computer just said to them, the answer is 42. So the fact that we have 42 countries signed up to International Moon Day makes me think there's a very bright future for the event. Which is a follow-up question for you, NASA. How would you like to see the International Moon Day develop?
Through cooperation, this is what it's all about, really. It's about cooperating all over the world, space-faring nations and space-emerging nations, and getting all the youth excited about research and about lunar exploration. Keep in mind that if we're going to have a lunar laboratory in 2040, these are the young ones who are in their early 20s now, who would be prime candidates to actually occupy these laboratories for stints of up to 2 years on the moon. So I'm afraid you and I, Stuart, we might not make that, but the young ones, yes.
We wish them well. And on the subject of this, of bringing people in and cooperating with the International Moon Day, every year we'll be releasing a call for people to organize events around the world. And as you heard from NASA, there's events now in over 42 countries this year. So watch our website, think of something that you can do, bring people together to talk about the moon on the 20th of July next year. Let us know, and why not? Let's see if we can get into triple figures for the number of countries that we can have Moon Day events in next year. So NASA, as you say, the chances are very high that at least some of the people watching this broadcast will indeed be walking and even working on the moon. So the question becomes, how will we get them there? And Tonya, this is in your remit. Getting the astronauts to the moon is going to be in the first instance, going to be the job of the Orion crew capsule. Now, you gave us a brief introduction to it earlier. I think you sold it short. It's such an impressive piece of technology and engineering. Tell us more about it. In particular, this idea that it's a deep space human-rated vehicle.
Yes, Orion has over 256,000 parts on our spacecraft, so I could spend all day talking about it. But in the interest of time, just to give folks a context, I'll focus on the high-level components of the Orion crew and service module. And you'll see it behind me. I've tried to move to the side so you can see it in my Zoom background. We have the service module, and that's built by Airbus and delivered through the European Space Agency and built by Airbus in Germany. And that provides the primary propulsion and the solar arrays for power and all of the consumables that are needed during our missions. We also have the spacecraft adapter and the spacecraft adapter jettison panels. You don't see it in this picture because those are what protect the service module on the pad and during launch. That beautiful shiny spacecraft is the Orion crew module, where our astronauts will live and work during our Artemis 2 mission. Orion can sustain a crew of 4 for up to 21 days in orbit during its initial missions to low lunar orbit. And the missions to more distant destinations may have a crew of 2 to allow more room for consumables on board. Each of Orion's 4 solar array rings are made of 2 3-bedroom homes. Orion's designed to provide the assured crew return in the event of any multiple system failures. We have a backup flight computer that does we have manual control of life support systems, manual control of communications and navigation aids. When you see it on the pad, you'll see on top is our launch abort system, and that's to protect our astronauts in the event of a launch abort. The goal is to never have to use it, of course, and just jettison it with each mission, but nonetheless, it's an important capability for our human-rated spacecraft. But when you talk about what's different sending astronauts into deep space, because we have a lot of things with commercial crew at the low Earth orbit, but the spacecraft returning from the moon, it re-enters the atmosphere at higher speeds than from low Earth orbit. And so we need thermal protection systems above and beyond the crewed vehicles to date. Orion's heat shield has to withstand re-entry temperatures equivalent to the surface of the sun, so about 5,000 degrees Fahrenheit. And of course, we're dealing with different radiation environments between low Earth orbit and deep space, from the relative safety of the low Earth orbit and having Earth's magnetic field to the intense magnetic fields of Earth's Van Allen belts, and then, of course, the environments of cislunar and deep space. So once astronauts start bringing astronauts home from the lunar surface, we'll be able to carry over 220 pounds of lunar samples back to Earth. We were talking about that earlier with Oz and how important that will be for science. And we'll have additional support for science for generations, just like how the Apollo era samples are still unlocking new scientific discoveries today.
Now, one thing we mentioned or we chatted about last week, which was which I'd like to ask you about again, because it was a lovely image. If only this were possible, if only the passage of time would have allowed this. But if we could take Neil Armstrong and Buzz Aldrin and sit them in the Orion crew capsule, would they still recognize it as a lunar capsule from their time in Apollo?
It would definitely be familiar to them. However, Orion's crew module provides about 30% more cubic volume of space in the Apollo capsule. And it has about 50% more living space than Apollo, allowing more room for the crew and tasks and supplies. But there's also significant system level differences between Orion and Apollo, including modern features like flight computers, advanced composite materials, 3D printed parts, solar arrays, and of course that improved heat shield that I mentioned. Apollo ushered in the era of computers and software, and Orion capitalized on a half century of computing advancements. These innovations really flight before a crewed mission is launched, all of that really enables that autonomy, and that being able to do that uncrewed flight test drastically increases the safety for our upcoming crew test flight. On Orion, also the guidance, navigation, and control systems, that's really the flight computers, the displays and controls. The optic measurements and advanced software are also much more complex and much more automated. We have about 1,200 sensors, and the crew module has a glass cockpit with screens and user interfaces reflective of our digital age rather than the analog systems, of course, that we had on Apollo.
Let me take myself off unmute there. We just, obviously this is going to happen in a live broadcast, but we've got someone cleaning the windows of the office and whistling very out of tune. So apologies if you can hear that. Look, thank you all so much for your time. Honestly, I could sit and talk to you all for the rest of the day. I've got so many more questions and just want to sort of get brain dumps from all of you because this is just so fascinating. But we are on a time schedule, and so we are drawing to an end for the panel discussion. But before we finally close, we're going to go around for one last quick fire round. And this time the question is, in a sentence or two, what does the future of lunar exploration look like to you? And because I've completely forgotten the order we went in to start with, I'm going to start in the room at Korea, and we're going to work from the table that's my right. So this time it's NASA to start us off with his vision for what the future of lunar exploration should look like.
My vision is that it's going to be technology driven, but also with an eye for preserving the lunar environment and responsibility. So technology, preservation of the lunar environment, and responsible management.
Thank you. So Young, what is your vision for the future of lunar exploration?
Right. I think, and I really wish that many more countries will participate in lunar program, as NASA talked about, and I happen to take part in International Space Exploration Coordination Group, ISIC-G, and ISIC-G has released the updated lunar surface exploration scenario last year. And one of the objectives listed there is to provide a large number of collaboration opportunities for international partners. And the target set there is to see more than 100 nations participate in lunar surface activities. And I really hope, and I think we can make that a reality. Thank you.
I think so too. Tonya, what's your vision?
You know, I was thinking along the lines of what they were saying as well. But the other thing that I think is really exciting with the new technology is that when we have lunar exploration with all of our connectivity that we're going to be able to have, that it'll be accessible to the general public much more than it was before. You know, where folks are exploring on the lunar surfaces, they have iPads, people can connect back home. You know, you can get on and connect with it and really energize and inspire the youth to really be a part of science and exploration.
Fabulous. Garvey, what about you?
Yeah, I just wanted to say thanks for having me on today, and what an exciting panel, and what a great, exciting group of experts. So as I really feel humbled to be a part of this group. But I think from my perspective, I mean, I think excitement and continued discoveries. I think, you know, when we go to the lunar surface and we're all working there together, I think there's going to be so many things that we can't imagine now that are going to happen going forward. So I'm just really excited about all the opportunities and inspiration that come from that. So I think if I had to have two words, it's just excitement and new discoveries. Thanks.
Fantastic. Michelle, what about your vision for the future of lunar exploration?
Oh, look, I really think, and it's in line with the vision of Rose, really. I hope that the future lunar exploration is one that does bring multiple industries together. So not just countries. I think the future is really about using lunar exploration as a focal point so that we can come together, you know, on a common journey that we can explore in a smarter way, a faster way. You know, on Earth, we need to achieve our decarbonisation goals. We've got a level of urgency to do this, and I really hope that we can leverage lunar exploration and bring, you know, many people along the journey and inspire many people as well along the way.
Indeed. So Oz, that gives you the final word.
Oh, thanks everyone. And I think most of the words have been expressed already, but it's exciting. It's collaborative. It's about international partnerships. But I really liked Tanya's comment about, being accessible too. I think that's important. And, also diverse and inclusive, this next going back to the surface of the moon, in orbit around the moon. I think there's a big focus on, increasing diversity and inclusivity in everything we do. And I think that's really exciting too.
Wonderful. Well, thank you all once again for your time and your expertise. We are in your debt, and anything that the International Moon Day or the Moon Village Association can do to help you realize these visions, we're all here to help. Now, there's one other person that I want to particularly say thank you to, and that's Gwacheon, because she's been working frantically in the background to keep us all running, changing our camera angles, running our videos. But she doesn't get off that lightly, because she's still got a bit more work to do, because now we have a video to watch from the Promo Moon initiative.
We are looking forward to the third edition of our Promo Moon initiative. 2 times it was already done, so it makes already a tradition, but we do not stop here. And please stay tuned for the third Promo Moon initiative, which is going to be announced quite soon this fall.
Well, as we say here at International Moon Day, together we can make the moon a laboratory for peace. And with that thought, I'd like to hand it over to NASA now in Korea, who will make some final remarks.
Seventh Global Moon Village Workshop and Symposium, which will be held December 6th to 10th in Kurashiki and Tottori in Japan. And also, I'd like to thank Lockheed Martin, Laura Champion, the Korean National Science Museum for hosting us, Antonio Stark for organizing, Stuart Clark, Dr. Stuart Clark, thank you so much for your help throughout the year. I would like to thank our Board of Advisors and our Oversight Committee for the International Moon Day, and of course, the distinguished guest speakers today, joining today. I would like to also thank Giuseppe Ribaldi, John Mankins, Glafki, Antonio, and Bernadette Ditera, and everybody who I did not mention due to my poor memory. So thank you so much for making it a wonderful year. Thank you.
Thank you, NASA. Well, that just about wraps it up for our main streaming event here for International Moon Day 2023. As you heard earlier, there are regional events taking place in more than 42 countries around the world. So be sure to check out our website, see if you can get along to one of those today. Thanks to your support. The day is growing, and that means, as we said earlier, we will be back next year. We're already looking for our host country for our big main event. So if you want to help us organize, then please get in touch via our website. As NASA says, thank you to everyone who's made this day possible, and special thanks as well to NASA for driving this all forward. So I'm Stuart Clark, and wherever you are in the world, we all look at the same moon. And I think we all dream about a peaceful future of discovery and exploration as well. From all of us here at International Moon Day, goodbye for now.